Hi, I'm David.
And I'm Adam.
And today we're doing our evap system lab sheet on a 2005 Suburban.
All right, so we were testing the circuitry on the system. We got the snap-on scan tool over here, which has a super useful feature where we can seal the vent and purge it. So, David, do we have a light connected down there?
We're about to. Right. So right now we're going to be connecting this test light to show that we have our power and ground when it is engaged.
Okay.
Somebody didn't press the button.
Yeah. All right, Anton, go ahead and actuate
There we
it. There you go.
So now we can see that we have some continuity there.
Yeah, so basically, what's going on is Anton is commanding the PCM to ground out that circuit, which is turning our light on.
So when looking under the vehicle, we were just looking for if we could find anything that could be clogged or basically send this code to the evap solenoid. And so when we were looking at this vent, we ended up finding the tubing next to it that was coming out of the fuel tank. And we ended up determining that was no cause for it, but we noticed that it was kinked. So we ended up taking note of that.
So we are going to run another test. We're going to test if the vent itself is actuating. David's got a stethoscope down there.
I'm listening for a click.
He's listening for a click. So Anton, go ahead and seal it. Hearing anything, David? Nope. Here, actuate it, close it, open it as much as like just back and forth. Not hearing anything? Okay. I think that determines we basically got a bad vent on the Suburban.
So this is our evap canister vent solenoid, and we ended up making a test on this for positive power and ground, which we ended up going to the negative battery terminal because the ground was too rusty to get under the vehicle. So we ended up also testing for resistance, and we ended up getting OL, which meant it was open. So that connection for the vent solenoid had power and ground going to it, yet that solenoid would not activate because of debris built up inside of it. And we could tell when we activated it because we could not hear a click with the stethoscope. So when we diagnosed this and ended up removing it from the vehicle, we could see all the debris that was built up inside of there. There was sand, rocks, and there was even spider webbing that was inside of there. And the reason that this can happen is because when driving on gravel, all those tiny sand particles can get built up within that canister and end up having this connection read open because it's just clogged with all of this debris. Alright, so after looking that we had our knock sensor codes, we went to verify the connection, and these should be a 2-wire connector going to knock sensor 1 and 2, which you can see are in the valleys under this intake manifold. And right now we're going to be looking at the voltage when Adam starts the car. All right, so now we're getting the readings, and we're on the signal wire for knock sensor 1 right now. And rev it up. And as we can see, we're reading from 0.6 volts to around 1.2, and it's varying in range as he revs the motor. All right, and now we are on the second connector right now. And our voltage at idle is reading around 0.4 volts. Adam, you want to rev it up real quick? And as we can see, we are reading around 0.8 volts. Alright, so this is an exploded view of my evap canister on a 2012 Infiniti G37. So the components we have on here, for number 1, that's going to be our evap canister system pressure sensor, and that's going to monitor the pressure within that canister. And then our number 3 on our diagram here is going to be our evap canister itself, which has a charcoal substrate within it, and basically that limits hydrocarbons that come from your fuel vapors. And then we're going to have number 5 on our diagram here is going to be the evap canister vent control valve. And this control valve basically It restricts fuel vapors that are made up in your fuel tank from getting out into the atmosphere by trapping them and then holding them within that canister.
Hello. All right, we're back. We've got this diagram set up right here about my 2014 BMW 335i's evap system. We're just gonna go ahead and give you guys a quick component naming and a quick component explanation. Here we have our filler neck. This is where you put the fuel into the tank. And here we have our ORVR system, which will collect the fumes as the tank is filled up. We have one line connected to this vent line right here, and we have another line connected straight down into the fuel tank. This vent line is also on the top of the fuel tank. It is our charcoal canister feed line. Our fumes rise from the fuel tank, go through this line, straight into the charcoal canister where it catches those hydrocarbons. Over here, we have a vent solenoid, and right here we have our vent line and evap vent, along with a evap vent filter as well to stop dust and sand from getting into our system. This solenoid here can close and shut off the vent for system testing purposes, whether we're purging the system, it can open it up, or whenever we're testing the system for leaks, it can shut the vent and to see if we maintain vacuum. And yeah, that is pretty much everything this diagram's got to show me. I'll move on to the next clip.